Hi, today uh, I want to show you how to solve a problem in ordinary differential equations. A mothball loses mass by evaporation at a rate proportional to its instantaneous surface area. If half the mass is lost in 100 days, how long will it be before the radius has decreased to one half its initial value? How long will it be before the mothball disappears completely? So in our solution, we need to find our initial values. At time 0, our, our m is equal has also an initial value of m sub o. R is equal to r sub o. So nothing has changed. So at 100 days, our mass decreased to half. Then we assume that at time 0, the mothball has a uniform density. So R density is equal to mass over volume. R volume is equal to 4 over 3 pi r cubed. So its derivative is equal to dv over 4 pi r squared dr. So plotting the initial value, R density is equal to initial value of our mass over R volume 4 over 3 pi R initial to the cube. In this equation, you can see that our change of mass over change in time is equal to K constant times R's area. So change of mass over change of time is equal to K times 4 pi r squared. So by the help of our density, m over v is equal to r density, we can get the m is equal to v times density. dm over density dv is also equal to dm equals to density times r dv is equal to 4 pi r squared dr. Substituting our density is equal to this formula. M sub o is equal to 4 over 3 pi r initial cube times 4 pi r cube dr. Then we can get our change of mass is equal to 3 initial value of m r squared over initial value of r dr. After we get our change of mass, we will back to our values time equal to 100 days. So at 100 days, R density is equal to 1 half initial value of m over r of our 100 days. So mass initial over 4 pi over 3 r initial cube is equal to 1 half m initial over r over 100 days. So simplifying, we get r over 100 days equal to 2 pi r initial to the cube over 3. dm over dt is equal to k 4 pi r squared. So we substitute our value of dm is equal to 3 m initial r squared over r initial cube dr over dt is equal to k 4 pi r squared. So, we get RDR is equal to K 4 pi R initial cube over 3 M initial dt. Integrating both sides, we get R is equal to 4 pi over 3 times K R initial cube over M times time plus C. So at time 0, we have R initial equals to C. So R is equal to 4 pi over 3 times K R initial cube times time over M initial plus R sub O. So Rk is equal to 3 M sub O times cube root of 1/2 minus 1 R initial over 400 pi R cube R initial cube plus R initial. We get cube root of 1/2 minus 1 times R initial over 100 T plus R initial. Then we have RR is equal to negative 2 times negative 2.063 times 10 to the negative 3 R T plus R initial. So R equation is equal to R sub R initial times 1 minus 0.002063 times time.